All right, geometry. We're looking at section 10.4 here, talking about perimeters and areas of similar figures. Okay, so let's get right into it. All right, so here is the main idea. All right, if we have two figures that are similar, then they have a scale factor, right? And that scale factor is how the corresponding sides compare their ratios, the idea of sides being proportional, right? So A over B, right? If that's the scale factor, then the ratio of their perimeters, is exactly the same thing, A over B, right? So if we take, let's use pre-image and image. So this is the coordinate plane notation. So the perimeter of the image over the perimeter of the pre-image is going to be equal to the scale factor A over B. Okay, but the ratio of the areas is going to be the scale factor squared, A squared over B squared. So again, this ratio of perimeters is equal to the scale factor, but then the ratio of the areas, so area of the image divided by area of the pre-image, that ratio will be A squared over B squared. That is the scale factor squared. Okay. So I think the easiest thing to do is think of units, right? So when you deal with perimeter, right? Perimeter, your answers are in units like feet, inches, meters. But when you do area, it's in units squared. So just keep that in mind when you're doing these problems. Now, again, you're going to see a lot of what we do here. So for instance, if I take this ratio, so the area of the image over the area of the pre-image equals the scale factor squared. We're going to be trying to use one to find the other. So to solve this, or to get rid of the fraction, if I multiply both sides by the area of the pre-image, they'll cancel. To find the area of the image, the new figure, you simply are going to take the scale factor squared and multiply it by the area of the pre-image. We're going to use this a lot in our problems, and you'll see what I mean when we get into some delta math questions. You would do the same thing with the perimeter. So again, if I want to bring this down here, right, the perimeter of the image over the perimeter of the pre-image is equal to the scale factor. Again, multiply by the denominator, the perimeter of the pre-image. They cancel. To find the perimeter of your image, your new figure, you simply take the scale factor and multiply it by the perimeter of the pre-image. Okay. So again, we did this when we did similarity back in chapter 7. Okay, so let's take a look here at an example, an explanation, right? Why does this work? Okay, well, let's take a look at the perimeter first. Now, we have two right triangles here. Notice that the scale factor is n. Notice that this 3, 4, 5 triangle over here, each of the sides is multiplied by n. Okay, so let's use this as the pre-image and this as the image. All right, so what is the perimeter of the pre-image? Well, we're going to add up all the sides. 3 plus 4 plus 5. That is 7, and 5 is 12. Well, what's the perimeter of the image? Well, that's going to be 3n plus 4n plus 5n. What you can do is, because each term has an n, you can factor out the n, and it's just 3 plus 4 plus 5. That is 12n. So if we take the ratio of the image over the pre-image, the perimeters of them, we are going to get 12n over 12. The 12s cancel, and there's n. N is your scale factor. So the ratio of the perimeters is the scale factor n. So again, that's the scale factor. Now, let's take a look at the areas, right? So let's find the area of the pre-image. Well, the area of a triangle is 1/2 base times height. That's 1/2 of 3 times 4. That's 12, and half of 12 is 6. So let's find the area of the image, the bigger triangle. Well, that's going to be 1/2 of 3n times 4n. So we can still do 3 times 4 is 12, and half of 12 is 6. But now you have this n times n, and n times n is n squared. And now, when you took the ratio of the image over the area of the pre-image, you're going to get 6n squared over 6. Those 6's cancel, and you're left with n squared, and that is your scale factor squared. Okay, so when you do these problems, you don't actually need all of the side lengths in order to find the perimeter area of one of the similar figures. If you have the scale factor and the perimeter area of one figure, you can use it to find the perimeter area of the other figure. Okay, so this was the explanation video. There's going to be a delta math video, and then there will be a short edge elastic video as well. All right, so look for those next videos.